acid cycle. And it's going to, in the process of each glucose molecule process, it'll cycle twice, 2 times. 2 times for every glucose. All right. That's how, this is called decarboxylation. So this movement of pyruvic acid inside the mitochondrial wall is called decarboxylation of pyruvic acid. Okay, there's some other stuff that happens. I'm not going to go into it. Like you get CO2 from this and so on. Alright? But it can show you what's going to happen next. Here, this TCA cycle is the Krebs cycle. And the Krebs cycle will make 2 turns per glucose process. And out of it, you're going to get 2 kinds of hydrogen carriers. You get NADHs in dominant. The dominant hydrogen carrier is NADHs, but you'll also get 2 FADH hydrogen carriers. And you'll get CO2, and you will get a measly number of 2 ATPs.
I can't see what you're pointing at.
All right.
What did you just go over? Can you say it again?
I said that you have, in the TCA cycle or Krebs cycle, 2 terms of it will get 2 FADHs, 2 ATPs, and a bunch of NADHs.
So 2 FADHs?
2 FADHs.
And
2 ATPs.
Okay.
And a bunch of NADHs.
Okay.
That's the major hydrogen carrier. You didn't get much ATP from this whole process so far. You only have 2. 2 from the glycolytic step, 2 from the Krebs cycle. And you're going to get around 38 of them. So the importance of the Krebs cycle is basically to produce energy-rich hydrogen carriers, namely NADH2s, or the NADH hydrogen carrier. What? The primary purpose for the Krebs cycle is to produce hydrogen-rich carriers, energy-rich hydrogen carriers, and the primary one will be the NADHs. NAD, and you don't have to know what it means, but it is a very, 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 very important carrier of hydrogens. Well, what do you do with all these hydrogen carriers? You had 2 from the glycolyc step. You've got several from the Krebs cycle. So all of them are going into the next system, which is called the electron transport system, or the chloroform hydrogen transport system.
Wait, what?
And they're going to manufacture, it all depends on the book, 38 to 34 ATP molecules. Now, I shouldn't have to tell you this because it's already been discussed, but I will. Because this process in the electron transport chain is an oxidation reduction process that we have already discussed. I didn't call it oxidation reduction, but I did show you the following. This is very important. Remember, all of the processes that you learn about, active, transport. You've learned about sodium potassium pump. You've learned about the processing of getting things
What
into
page
the
of the book
cell.
that is?
Well, all of us required ATP.
Hmm?
And ATP, from way back in chapter 2, I told you that you had an ADP, 2 phosphates. And what you have to do is you take the ADP and take a phosphate molecule and you combine the third phosphate to the diphosphate. It takes a lot of energy to do that. Like, remember the mouse trap that I brought in? The rat trap. And what happens is the energy needed to tie that third phosphate onto the diphosphate comes from a hydrogen electron, either from FAD or NADH. They give up those hydrogens. And that energy is used to force the phosphate to tie onto the diphosphate to get ATP. That was covered in chapter 2. Okay? Now, anytime you have to break bonds, anytime you have to do energy or utilize energy in the body, you've got to break that third phosphate loose. So it's a reversible reaction. You will take that phosphate bond and break it, providing your body with energy, and convert it back into a diphosphate and a free phosphate so it can go back through the cellular respiration process. Now this is really watered down stuff. In micro, they go into all of the intermediate processes of this transition. But I ain't touching that one. I'll let them fool with that. But you can't even believe how little I'm teaching. So when you feel that this is really hard and terrible, ooh, I have a bad piece of information for you. Micro is going to kick some tail end. And that's why I'm telling you, learn this now to this level so it's not so hard in micro. Alright? Alright, now I'm going to go back through it. I'm going to use some transparencies that will break it down in another way. I'm going to go to 3 different ones. First off, we're going to look at glycolysis. And I'm going to tell you exactly. See, y'all didn't believe me. I wish you'd pay attention to me and think I'm not trying to pull your leg. I showed you like on the muscles. I showed you all exactly what was on that test. I did it. I showed you the rotators and told you. You are going to